I don't want to waste your time, so there won't be any intro. A lot of you asked me to make a tutorial on implementing metahumans as NPC, so here is this tutorial. This tutorial will be split into 4 main categories. First of all will be obtaining the metahuman. Second will be configuring and optimizing the metahuman. Third would be setting up its movement. And fourth is optional, that is setting up its state of combat. Now let's get into it. First of all, we need to obtain the metahuman, right? So for that you have to go to your Quixel bridge, and if you don't know how to go to a Quixel bridge, just simply click on this add and go here Quixel content, and it will open another window. I've just put it here, and when you log in using this particular button, you log in and you'll have your own metahumans section here. If you don't see it by any chance, then just try to restart the editor, or maybe try and save your metahumans on the metahuman creator website. When you'll go here, you'll have all of these metahumans available, which are the current versions. Try to get this current version because the legacy ones won't work anymore with 5.2 and above. So let's pick any metahuman. For example, you just have to click download and then add here. Okay, so it will take some time. I'm not gonna do it because I've added all of the metahumans already in my project. And by the way, my project is Salvation Hours. You can check it out on Steam. Anyway, so I will recommend to get the low quality here, because low quality on its own is very good in terms of the overall aesthetics of the metahuman. Low quality is a good starting point for any game that you're making. Just set it to low quality, simply download it and export it. It should be, after downloading, it should be somewhere here in your metahumans folder. Okay, so in this particular tutorial I'll be just focusing on enemies. So just keep one thing in mind, that enemies should act opposite to your friendly NPCs, right? After adding that particular NPC, let's say I'm going to add this particular NPC, the enemy one, because it suits this tutorial. So I'm going to obtain this, and I'm going to have a folder here. As you can see, we'll have a blueprint by the name of your own metahuman. You'll click on it and this should open it up this way. When you go to the viewport, you'll see your metahuman just standing in the A pose. Okay, so all you have to do, you just have to select this body. Okay, find this particular skeletal mesh right here by clicking on this browse to asset button, or just simply pressing Ctrl B here, and you'll get this particular thing. As you can see, it's under metahuman, the name, which is enemy in our case, and under the male body, you just have to right click skeleton and then assign skeleton. Okay, now try to assign the UE5 skeleton. This is only for those who wish to use the Unreal Engine 5 skeleton as their choice in this game, like I did. If you want to retarget your own metahuman skeleton and you have your own metahuman animations on that skeleton, don't do this step, just skip to the next one. Okay, this is only for those, or for people like me, who decided to use the UE5 mannequin. Okay, just click on it and then accept. As you can see, all of the bones will be converted, and this, if you can just simply skeleton and find skeleton, you will see it's the UE5 skeleton, which is what we required in that case. So now your enemy has the correct body. Okay, you're not gonna use this particular blueprint as your NPC. So now let's make a blueprint quickly. As you can see, in our case, it's the NPC master. So for the workflow of Salvation Hours, which is my game that I just released, I decided to use this character blueprint. As you can see, the parent class here, character, I decided to use the character blueprint as a master parent blueprint and derive children off of it. So all of the components you see here on the left are all of the components that are placed in the parent blueprint or the master blueprint, and all of the children inherited simply, and that children also are what enemy blueprints that we have here. Okay, basically every blueprint of every NPC is just a children of this master blueprint. Okay, so what you have to do, make a master blueprint by using the character class, and if you don't know how to do that, you can just simply make a folder, right click, go to the blueprint class, select on this character, and then just name it my character or whatever it is. You can see when you'll make a character, you'll have a few default things, which will be the capsule, the character movement, and the mesh itself. So all you have to do, just make your master blueprint like I did. Okay, as you can see, it's technically empty. add all of the components you want. It doesn't matter if it's an audio component, a weapon, or whatever it is. Just add your components and simply just add your static meshes slowly. Now since this is not required, I'm gonna delete it right here. So after making your master blueprint, all you have to do is just make a child blueprint by simply just going right clicking and creating a child blueprint class. You can name it enemy, as I have in my case, as you can see, BP NPC enemy. When you will do that, you can see all of the components are here, which are inherited from the parent one, and the parent class is shown on top right, BP NPC master. So this one is actually a complete blueprint, but what you have to do is just take this body, basically this skeletal mesh, find it, select it here, go to your desired children blueprint, select the mesh, and then place it here, okay, by clicking this button. So it will replace the mesh. This will be empty by default, so you click on it and it will replace the mesh. After that, just go back to your original Metahuman blueprint, take all of these components along with the LOD sync. As you can see, that means the feet, the leg, the torso, the face, and all of the groom components and the lot sync. Just copy it and place it. As you can see, we have feet, torso, face, all of the groom components, leg, okay, and of course the LOD sync component. So we have all of these components here. So our Metahuman essentially is now complete. So this is the stage 1, which is setting up and configuring your Metahuman. Now let's move on to stage 2, which is optimizing, and that is a crucial part, okay. The first very simple thing one must do for optimizing metahumans is go to your face and find all of the groom components, okay. In my case, I actually place a balaclava on their face or a bandana, so that actually hides most of their groom components, the mustache, the eyebrows. So I tend to just hide them whenever I don't want them. So that's a custom thing I do. You can choose and just skip this part, okay. Now let's go to all of this. Let's say we go to eyebrows, okay. You can notice this thing, eyebrows M missing. This is the groom asset. Just go here, okay, just open it up and you'll have your groom asset, which you can see here, okay. If I unlit, I guess you can, yeah, you can see it in a better visibility now. This is the eyebrow asset, and as you can see on the right, it says cards. For you, it's not going to say cards, it will be meshes here, okay. So all you have to do, just simply decimate this object, okay. I can take a live example. Let me fetch a live example. Yeah, so here we have our live example. This is one of the bears that I'm using in the game. When you'll open this, notice just this section, okay, LOD0 right here. It will be in such a format. The curve decimation here will be 1, and the vertex decimation will be 1. As you can see, these are the default values, and by default it will be strands. I'm again reminding you, all of the LODs you see down here will be strands, okay, and strands are very computational heavy, so you just have to turn them into cards. So first of all, notice this curve value. It says 16,000. I don't need that much. It's totally stupid. So I'll reduce it by a lot. So I'll make it, let's say, 20% of the original. So I'll just pick up 0.2. It will recalculate everything, will turn down to 3200, which is just double of our LOD1, which is good. Once again, vertex decimation can be set to 0.45 in our case, as you can see. Now, by decimating this groom component, we have reduced the total number of polygons that can be rendered on this LOD. Now just simply switch it to cards, because again, cards are computationally less expensive than strands, and done. This is your groom asset now. Now there is a command that you have to use, which is this, the first one, okay. This command is very essential. You have to use it and simply just enable cards so that you can use cards. If you are not able to switch to cards, you have to use this particular command and you will be able to use cards. Now let's move on to the next step. Yeah, so what I was saying here, you just have to go to all of the groom components, do the exact same step that I told you. Just have to rinse and repeat, okay. You have to take this. First, you'll have to open it, you'll have to go here, you'll have to decimate all of the LODs according to how you want them. You'll have to convert them slowly to cards and save it, okay. Now there is a good chance some of it may not be visible here after decimating. Now that can be solved by going here in LOD sync, okay. Try to have these numbers as close as you can be, okay. LOD2 is very good given all of my enemies can be very close to the player. So LOD2 was just perfect. As you can see, LOD2 here, 2 here, all the way it's LOD2. Okay, except for this, but yeah, LOD2. So what this will do is it will allow you to have more control, granular control on the LODs of your Groom components that are matching with the body mesh. And if somehow, for some reason, they are not visible, just go back to your Groom component, whichever one is not visible due to some reason, and make sure you check this visible thing here. Okay, so in my case, let's take eyebrows. Okay, I guess you can see the eyebrows, right? So if I go back to eyebrows and I pick the Groom asset here, as you can see, it's visible on LOD1, LOD2, but not on LOD3. If I disable these two and save it, you'll notice the eyebrows disappeared. They still exist, but they disappeared, right? Because you cannot see them on that particular LOD. So remember, you have to enable their visibility on that particular LOD. In my case, I can simply turn off LOD0 and 1 and just have LOD2, and that is the only thing I need, because like I said, all of my LODs are set to LOD2 in this case. Now we have set up the Metahuman. As you can see, the eyebrows are back. Now we have set up the Metahuman, we have configured it, and now we also have optimized it. Now let's move on to the actual code. So this is the master blueprint, as you can see here. Remember, you're gonna need a controller, okay, an AI controller, something like this, the BP NPC AI controller like I've made. You're gonna need one of this controller and hook it up to your NPC master class. Remember that, because without it, there's nothing that's gonna happen. Okay. Anyways, so moving on now, it's about the movement and the combat system. So first of all, just remember one thing, that for movement, I'm gonna close this window right now. For movement, yeah, you gotta have a navigation mesh right here, as you can see. Without that, they're not gonna move. They need to have some sort of a movement place to go. Okay, so just get a nav mesh bounce volume, and if you don't know, just check another tutorial on how to get a nav mesh bounce volume. It's very simple. You need to give them a place to walk, right? Now if I go back to the blueprints, the only key factor that we have is movement and the combat state. So the movement solution in my case is a very custom solution. I won't recommend it that you should use it such like directly as such, but try to modify it. Okay, so what I'm doing is I'm just making a blueprint interface function. It's an interface function. If you don't know about interfaces, you should. Actually, it's a good thing. Just make an interface. In my case, it is this BP, as you can see, BP int yani interface NPC, and I can just make all of the functions that I want to be implemented in this blueprint, and I can call it from anywhere. Okay, if the target implements this interface, which by extension is every child of this class, then yeah, you can access this function. So I can pick any of these characters here, any of these, and I can call that function move target. This move target AI points, sorry, AI target points, I can call this function and they all will move. Now from the name, it's pretty obvious that this whole thing revolves around target points. So this is a target point, just like any other actor in the world. It's a target point. Okay, and it is supposed to give you a location header as it's an actor on its own. So in my case, what we do is we make a blueprint variable here. Where is it? Yeah, target point. Okay, as you can see, we make a blueprint variable here of the type target point, and it's an array. So let's say I want my character, this particular character, to move. So what I'll do, I'll make this variable, I'll make it instance editable and public, and I'll go down, and as I can see, target point is here. So I can just add a few target points, right? I can just use this marker thing, dropper thing, and I can pick target points 1, 2, and if I do find the third one, 3. So now this character has a reference of all of these 3 target points in this world, right? As you can see here. So whenever I'll call this function, my character knows that he can walk from 0, 1, and 2 with a choice of 3 target points. So in that case, starting point integer is 0. The end point integer is 0, 1, 2. 2. So now my character can easily walk from 0 to 2. Now this boolean custom endpoint, what does this do? Well, if you have a lot of target points in this particular area, if you have a lot of target points and you only want your player to move from, let's say, 0 to 7 instead of 0 to 10, or you want them to move from 5 to 7 instead of 0 to 10, so you can use this boolean custom endpoint and just have them go crazy on the movement thing. Okay, so what happens is I get the starting integer, okay, which is the target point counter, and then I also get the end value here. So what I'm doing is I'm just getting the initial value, whatever that is. It doesn't matter, it's 0, 1, 2, 3, 4, 5, it can be any value. I'm getting the target point array of that child blueprint. I'm seeing if it is valid. If it is valid, then we are getting that particular target point. See, we have 0, 1, 2. If my starting integer is 1, I'm gonna get this target point, which is this one, I guess. This one. I'm gonna get this one, okay, this target point, because it's on index 1. So we'll see if it is valid. We'll move to it, and on success, ignore this please. On success, we'll see if it is a custom endpoint. As you can see the boolean here, if it is a custom endpoint, then what we see that is this counter, this target point counter, basically the starting point, if it is equal to the endpoint. Let's say you are moving from 5 to 7, so you have 3 target points. We have 5, 6 and 7. So if 5 is equal to 7, which is not, then nothing. But if it is, then we stop. So let's say you only want to move just 1 point. You only want to move from 5 to 6. So it will see first case is false. Okay, so it will go from 5. It will see that 5 is not equal to 6. So it will be like false, and it will increment it. So now that 5 becomes 6, and in the loop will run again. We'll see if it is valid. We'll get the value 6. Now we get the 6th integer, and then we see if it is valid. We move to it, and then we check. Now here comes that custom check. If 6 is equal to 6, which is true, we get that particular target point once again. As you can see, we just get that target point. We stop the movement, and we set the actor's rotation, and done. That's all. Now this part right here, this is a custom thing that I did, because in my case, and it happens with everyone I guess, that NPCs tend to fail their movement at times. Even though you have a big acceptance radius and everything else, they tend to fail. So I made this fail counter thing, that if they fail and if the fail limit has been crossed, then we just simply, as you can see, if the fail limit has been crossed, we simply stop. And if it hasn't, that means we can try once again. So as you can see, the true case, we try once again. So this is just a check to try once again, over and over again, even if you're failing, because it happens that there's a collision and you can just bypass it and move ahead, right? So this was the movement code. I can show that in action. Just wait. So here you can see that in the level blueprint, I've made a simple code that will be using this particular NPC, and we'll be just simply calling this function move AI target point. We are going from 0 to 2, and it's not a custom endpoint because we literally have just 3 target points, and I've moved them here, all of the target points. The first one is here, the second one is here, and the third one is here. So if I press play, and if I go here, and if I press 4, he's going to move here. Then he's going to come to the second one, as you can see, and then he's going to go to the third one, and now he's going to the third one again. Oh, okay, so maybe there's some, yeah, okay, so there's a blocking volume here, that's why he was not going here. I can just simply cut it off. So yeah, but you get the idea. Okay, he's going to move here and then here and then here. Because of the blocking volume, it was not moving. It's fine, but you get the idea. So now we have completed movement. Now let's quickly move on to the combat stage. The tutorial has been long enough as is, but I hope it helps a lot of you guys checking it out. Now moving to combat state, I'm not gonna go deep into this because you can make your own system and learn from various tutorials like I did, because this is a custom solution. But in essence, what you need is a pawn sensing component. Okay, and as you can see, a pawn sensing component, it's very huge, and I wanted it to be huge. You don't have to have it this big. Okay, it's bad for performance, but I had no other choice. You can adjust the radius, as you can see. You can reduce the radius, you can reduce the cone, but you're gonna need this sensing component. Okay, remember, on begin play, if you don't need the combat code, always on begin play, just disable the pawn sensing code. Where is it? Here, yeah. Just take the pawn sensing element, and it's a master server event, as you can see, so it works on replication. You can just disable it, right, and only enable when you need it. So what I used to do in my case, when there was a combat situation, I used to call all of the combat NPCs and simply just enable the pawn sensing on them. When I don't need them, I just simply disable them. So if you guys are interested, you can comment down. I'll make an in-depth tutorial about the combat situation only. But on a brief note, what happens is I check that if the NPC is combatant friendly, again, check only custom to my game. And then I set a few variables, again, I need them. So for the friendly enemies, only for the friendly enemies, you need to check that are you sensing the pawn which is enemy, as you can see. So these are the friendly NPCs, okay, these ones. And that red one here is the enemy one. So they can easily scan him using their pawn sensing component. So if it is true, then we see if that particular actor is valid. Then we rotate the actor, which in our case are all of the friendly NPCs. I'm directly rotating them, not adjusting their animation. It's just how I felt was correct. So you're rotating them so that they point at the enemy by finding a look at rotation. Again, it's just math. And then you are just you're getting the camera here. Using this camera, I'm getting the rotation and doing a line trace, and I'm simply setting if I'm doing a hit on the line trace. If I am, then I'm just applying the damage and then spawning something, bullets, and then I'm just activating smoke, flashes, etc., etc. And when I've done the same as a firing count, basically the weapon or a magazine count, when I've crossed 30, I'll just wait and reload. And that's pretty much it. So yeah, this is the combat state. And for the enemies, because someone asked me to make a tutorial specifically for enemies, what I did was, again, the same thing, that pawn sensing is disabled on the enemy as well, although it's already being implemented on the master blueprint, the NPC master, but I decided to just override it here again. Right, the enemy combat scenario is a bit different because for my game I had a different code going on. Okay, in this case I used to just simply spawn enemies here, okay, as you can see, setting their walking speed, asking them to move to the particular target points, the exact same code that I did last time in the NPC blueprints for moving them, and that's pretty much it. Yeah, but now on C pawn, which is pawn sensing, here it was different. I know it was the same function, I'm sorry. On C pawn, you have to use this function to basically use the pawn sensing component. So we are checking a few booleans which are necessary, and if the enemy is activated in my case, and if the pawn is jack, okay, if it is jack, which is our player, then it's cool. We just rotate towards jack by using a line trace fired from the camera. You can pause and read the code if you want. Okay, we are getting the rotation to look towards the player, which is jack. We are just simply firing it up, and we are applying damage if the line trace has hit jack. And then again, we are spawning the bullet projectiles, spawning particle effects, spawning sounds, and etc. And then reloading. It's the same code, okay, literally the same code, with the only exception that it's scanning jack, which is the player. And if it is not, then we are scanning this, if it is GRS or not. So remember, the player that we are Jack, okay, our name is Jack. I mean, the player's name is Jack, but all of these are friendlies and they have a different category, different tag. So I'm using that different tag here, actor hashtag. And just so if you want to know how to add a tag, just go to the class defaults, search for tag, you'll get this actor hashtag. Okay, add a tag here and you're good to go. So I'm just, if the enemy cannot detect player for some reason, enemy will try to detect the other friendly NPCs, the combat ones, and shoot them and damage them. But if he does detect the player, he'll shoot at the player. So the player is prioritized in this case with this branch. That's pretty much it. Yeah. I hope it was a much simpler explanation than I made it to be. If you have any doubt or anything, let me know in the comments. I'll try to explain this thing as best as I can. Once again, it's a custom solution. It's not a documentation or anything, or I haven't followed anyone else's tutorial, okay? It's my own solution, so it may not be as good as you were expecting, but it works, okay? The downside is that you need to have multiple target points to navigate the character. Let's say the one target point was here and you want him to come to this thing. So you'll have to make one here and then make one here. Sorry, just make one here. And if you wanted to turn, you'll have to make one more and then you have to make one more and then one more. So only then the path will be like this, okay, around this red car. So that is the only downside with my system. You have to have a lot of target points, like a lot of target points, but it works perfectly because it's following target points one by one. Just make sure to have them at the correct height, okay? The target points always need to be at the height of your character. So if they are at, as you can see, 3.5 z coordinates, so this also needs to be at 3.5. Why is it on minus? Yeah, so it should be on 3.5. So if I do it 3.5, it's up here, and this will be even more accurate for the player, so they don't have to calculate their z height in any case. So yeah, that's pretty much it, guys. That's a tutorial. Now we were able to set up an NPC and we were able to optimize it. We were able to set up its movement, and lastly we were also able to see how we can potentially set up its combat state. So I hope this helped you guys a lot, and if it did, then leave a like and subscribe and check out my game Salvation Hours. Link is in the description. It's available on Steam. I've used all of this and much more in that game. Just try it out and let me know how it is. Okay, until then, see you in the next one.